Hello students, hope you are doing well. So we are starting our online classes. You all know that we completed chapter number 1 of mathematics, that is relations and functions, and we completed half portion of second chapter, that is inverse trigonometry functions. Remaining portions I will complete after reopening the school. So today we will start a new chapter called matrices. Matrices. Its singular form is matrix. Matrix has got a lot of applications in different fields. In mathematics, mainly it is used for solving system of equations, system of linear equations, etc. It has got applications just like its notations are used for preparing electronic spreadsheets. It is used for cost estimation, result analyzing. Lot of applications are there. Okay, anyway, we can start the chapter. First, I will tell definition of matrix. Matrix is a rectangular array of numbers or functions. That means arrangement of numbers or functions in a rectangular form. For example, A equal to 5, 6, 8, 2, 5, 4. So we are arranging these numbers in a rectangular form. Okay. So these elements can be number of number of pencil, number of books, etc. So these are datas. Now another example, B equal to XY, can be variables also, AB. Usually we represent capital letters for representing matrix and small letters for representing its elements. So now it has got rows and columns. First thing you have to study rows and columns of a matrix. Rows. Consider matrix A. How many rows are there? This is called row 1. This one is row 2. 2 rows are there. And this one is column 1. This is column 2. This one is column 3. So first matrix A has got 2 rows and 3 columns. And matrix B has got 2 rows and 2 columns. Using columns and rows, we represent order of a matrix. Order. The first thing you have to study in this chapter is order of matrix. If a matrix has m number of rows and n number of columns, then order of that matrix is denoted by in this symbol, and we read it as m by n. If a matrix has m rows and n columns, then order of the matrix is denoted by the symbol, and we read it as m by n. Consider one example. Suppose consider matrix A. A equal to 5, 6, 8, 3, 4, 2. We want to find order of this matrix. This matrix has got 2 rows and 3 columns. So order of this matrix is 2 by 3. We usually write order in this corner. This corner of the matrix. So now I will write some question. We want to find order of the matrix. A equal to 5, 8, 9, 10, 3, 4, 8, 5, 1, 4, 6, 8. These are elements. What is the order of this matrix? This matrix has got 3 rows, right? And 4 columns. So order of this matrix is 3 by 4. 3 by 4. Let's have an example. B. 5, 1, 6, 8, 2, 1. What is order? Right? Matrix has got 3 rows and 2 columns. So order of this matrix is 2 by 3. Okay. The first thing that you have to study is order. I think now you understand what is order and how to find order of the matrix. And within this section you can expect some question. So consider this first matrix. Order is 2 by 3. Let's check number of elements in the set. Number of elements in the matrix. There are 6 elements, that is 2 into 3. Order is 3 into 4. Number of elements, there are 12 elements. Order is 2 into 3, that is 6. Number of elements are 6. So if order of elements of a matrix is m by n, then there will be m into n, mn elements. Mn elements in the set. So we can expect question this reverse also. If a matrix has got 12 elements, what are the possible orders it can have? Matrix has 12 elements, just like this one. 12 elements. What are the possible orders it can have? So one order is 3 by 4. Because 3 by 4 matrix has got 12 elements. And that order is 4 by 3. So we can represent these 12 elements as in 4 by 3 matrix also. Then another one is 1 by 12. 1 by 12 means 1 row and 12 columns. 12 by 1 matrix. Then 2 by 6. 6 by 2. 6 by 2. So if a matrix has 12 elements, we can form 1, 2, 3, 4, 5, 6 different orders of matrices. Okay. Now we study how we can represent a matrix in a general form. Suppose a matrix has got m rows and n columns. How we can represent that matrix? So we can represent matrix by capital letters and its elements by using small letters. So we will write like this: A11. A11 means first row, first column element. So this element will be A12, that is first row, second column element. Then this will be A13. We cannot write all elements, so we will put etc. And last element will be first row and nth column element. Right. Second row. This will be second row, first column, A21. Second row, second column, etc. A2n. Etc. We can put. Last row. There are m rows. So last row element will be AM1. Mth row, first column. A, M2, etc. AMN. So we will write order of this matrix here, that is m by n. So we have another method also. So the same matrix we can write like this: A equal to matrix Aij. Aij represent all these elements. 1 less than or equal to I less than or equal to order is m by n. So 1 less than or equal to I less than or equal to m. I vary from 1 to m. And 1 less than or equal to j less than or equal to n. J represents number of columns. In this way we can represent matrix in a general form. Generally we can represent matrix like this. Okay. Now based on this topic we can expect some questions like this. Construction of a matrix. For example, one question: construct a 3 by 2 matrix. Consider a 3 by 2 matrix whose elements are given by Aij equal to 2i plus 3j. We want to construct a 3x2 matrix whose elements are given by Aij equal to 2i plus 3j. So first you have to write its structure. So it will be like this. A equal to A11. There should be 3 rows and 2 columns. A12, only 2 columns. And A21, A22, A31, A32. So now we want to find all elements. A11. So we have to use this formula for finding A11. That means take I equal to 1 and j equal to 1. Substitute in this equation. So 2 into 1 plus 3 into 1 will be 5. Right. Then find A12. That means I equal to 1 and j equal to 2. So 2 into 1, 2 plus 3 into 2, that is 6. So A12 will be 8. Then A21, that is I equal to 2 and j equal to 1. So 2 into 4 plus 3 into 1, that is 3. 4 plus 3 equal to 7. A22, I equal to 2 and j equal to 2. So it will be 2 into 2, 4. 4 plus 6 will be equal to 10. Then A31, 2 into 3, 6. 6 plus 3, 9. Then A32. Take I equal to 3 and j equal to 2. It will be 2 into 3, 6. 6 plus 6 will be 12. So we have to write answer in this form. So A equal to matrix 5, 8, 7, 10, 9, 12. Question is, construct a 3x2 matrix whose elements are given like this. So you can expect a question like this for 1 mark or 2 mark. We can write one more question. Question is, construct a 2x2 matrix. 2x2 matrix whose elements are given by Aij equal to I plus j whole square by 2. This simple question. 2x2 matrix we have to form. So first we will write its structure. That is A11, A12, A21, A22. And we will find each elements. A11, this is our formula. So I equal to 1, j equal to 1. Substitute in this formula. It will be equal to 1 plus 1, 2, 2 square 4, 4 by 2, 2. Then A12, find A12. I equal to 1, j equal to 2. 1 plus 2, 3, 3 square 9. It will be 9 by 2. A21, again 2 plus 1, 3. 3 square 9, 9. So A22 will be 4, 4 square 16 by 2. That is 8. So A we can write like this. 2, 9 by 2, 9 by 2, 8. So we can study about different type of matrices. First one is row matrix. A matrix with only one row is called row matrix. Matrix with one row and any number of columns. For example, A equal to 1, 5, 8, 6. This matrix has got one row and 4 columns. So order of this matrix is 1 by 4. A matrix with one row and any number of columns are called row matrix. A matrix with one row and any number of columns. Now second type of matrix is column matrix. Column a matrix with only one column is called column matrix. For example, matrix B. Elements we can write like this: 5, 6, 8, 1. Means matrix with one column and 4 rows. A matrix with one column is called column matrix. So order of this matrix is 4 by 1. So different orders of column matrix are 5 by 1, can be 6 by 1, etc. Different order of row matrix are 1 by 2, 1 by 8, etc. Now third one is square matrix. Square matrix. A matrix with the same number of rows and columns are called square matrix. For example, A equal to 5, 6, 8, 1. Number of rows are 2 and columns 2. Order of this matrix is 2 by 2. We can read it as a matrix with order 2. We need not write 2 by 2 because number of rows and columns are same. So we can tell like this: a matrix with order 2. Second example, B equal to 1, 2, 8, 3, 4, 1, 1, 1, 0. B is a square matrix of order 3. Okay, because it has got 3 rows and 3 columns. In square matrix, we have to note one thing: diagonal elements of a square matrix. Diagonal elements of a square matrix are A11, A22, A33, etc. So in this case, diagonal elements are 5, 1. In this matrix, diagonal elements are 1, 4, 0. Okay. For a square matrix, there is only one diagonal, that is, and diagonal elements are A11, A22, A33. We cannot consider these as diagonal elements. We cannot consider this one as diagonal elements. Okay. Now, fourth matrix, that is diagonal matrix. A square matrix is said to be diagonal matrix if all its non-diagonal elements are zeros. All its non-diagonal elements are zeros. For example, A equal to, this should be a square matrix, and we can write element like this: 5, 0, 0, 0, 4, 0, 0, 0, 8. So non-diagonal elements are zeros. That is the condition. So diagonal elements are 5, 4, 8. And non-diagonal elements are 0, 0, 0. So we can write a definition in this way also. A square matrix is said to be diagonal matrix. A square matrix A equal to Aij is said to be a diagonal matrix if Aij equal to 0 for I not equal to 0. This condition you have to study. Fifth type of matrix, that is scalar matrix. Scalar matrix. A square matrix is said to be a scalar matrix. Or is a square matrix A equal to Aij is said to be a scalar matrix if Aij equal to 0 for I not equal to j. That means it should be a diagonal matrix, and Aij equal to k for I equal to j. Means all non-diagonal elements are zeros and a diagonal element should be same. For example, A equal to 5, 0, 0, 0, 5, 0, 0, 0, 5. Okay. non-diagonal elements are zeros and diagonal elements should be same. Can be 5, 2, etc. Now, sixth type of matrix, that is identity matrix. Identity matrix. Definition: a square matrix A equal to Aij is said to be an identity matrix if Aij equal to 0 for I not equal to j. That means it should be a diagonal matrix, and Aij equal to 1 for I equal to j. That means all diagonal elements should be 1. Example: A equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. Alright, one more example: B equal to 1, 0, 0, 1. Okay. Now, last type of matrix, that is type 7, zero matrix. Zero matrix or null matrix. A matrix is said to be zero matrix if all its elements are zeros. Need not be a square matrix. Can be a matrix of any order. Equal to 0, 0, 0. Okay. That's all about different type of matrices. The next class we will study is different operation on a matrix. So in this class we studied about how to construct a matrix, what is order and different type of matrices.